The average of 4 different positive whole numbers is 4. If the difference between the largest and the smallest of these numbers is as large as possible, what is the average of the other two numbers? I'll let my numbers be A, B, C, and D, and they tell me that the average is 4. So that means I have to divide by 4 to get 4. If I cross multiply, I get A plus B plus C plus D is equal to 16, correct? So now we have to make a little bit of a table and see what possible scenario will work for us. I want the difference between the largest and the smallest to be as large as possible. I'll let this A be the smallest and I'll let D be the largest. Okay? So, let's say the smallest possible number I can have is 1, because they're saying that they're all positive whole numbers. And the largest possible is going to be 16. But if D is 16, then D plus A will be 17, and that's not going to work, right? So let's make D 15. That way, this at least can work. 1 plus 16, or 1 plus 15 rather, is 16. But B and C would have to be zeros for that to work, and that's not going to fulfill the criteria of the question, because they're 4 different positive whole numbers. So this doesn't work. Okay, no problem. Keep going. Let's try 114. Well, it's 114, then this sum of B and C has to be 1. And their only way to do that is 0 and 1. But both of these numbers have to be positive, right? So that can't work. Okay, let's try 13. That means B and C have to add up to equal 2, correct? And the only way to do that without having a 0 is 1 and 1. But that doesn't work because all 4 are different. Okay, let's keep going. How about 1 and 12? Is that going to help me? Sooner or later, we're going to get something that works. 1 and 12, well, that means B and C have to add up to be 3. And the only way to do that without a 0 is 1 and 2. Well, again, we don't have 4 different numbers. Let's try 1 and 11. That means B and C would have to add up to be 4. And the only way to do that without zeros is 1 and 3 or 2 and 2. And neither of those scenarios give me 4 different numbers. Okay, how about 1 and 10? That means B and C have to add up to 5, and that can happen with 2 and 3. And this satisfies the question. So now they're asking for the average of the other two. The other two numbers are 2 and 3. Their sum is going to be 2 plus 3 and divide by 2 to get the average, and that is 5 over 2. So number 22, the answer is B. The list of integers 4, 4, x, y, 13 has been arranged from least to greatest. How many different possible ordered pairs x, y are there so that the average mean of these 5 integers is itself an integer? So 4, 4, and then x is either greater than or equal to, y is greater than or equal to, and 13 is greater than or equal to. So our sum is 4 plus x plus y plus 13. And to get the average, of course, you have to divide by 5. And that has to equal some integer. So if you do this math here, you get 21 plus x plus y divided by 5 has to be some integer. All right? So let's make a little table and off we go. So the table, this part will be x plus y, this part will be my n, and then x and y. So let's start with in the beginning. So looking at this equation entirely to fill out this table, x plus y could be 4, and that would make it an integer, and would therefore be 5. And now let's pick x's and y's. X plus y is 4, but x and y are such that y is greater than or equal to, so that's another important fact. What we can do is 2 and 2, or 1 and 3, right? But the problem is neither of these are valid because x has to be greater than 4. So these ones, no good. So I write them in, but they're not going to be ones that we choose because they don't work according to the conditions. All right, let's keep going. X plus y, the next one, 9. That way n will be 6. And now I'm going to choose x and y, so perhaps 4 and 5. And that's the only one. So I'll put a little check mark beside that one. Okay, so I hope you see the hang of this. Let's keep going here. The next one, to make that an integer, 14. And therefore n will be 7. And that would be 4 and 10 will work, 5 and 9, 6 and 8, and 7 and 7. These will all work for x plus y equals 14. So that gives me a few more. Put little check marks there that these are good ordered pairs. All right, keep going here. So our next one, 19, right? And that would make 8 for n. 4 and 15. But the problem is y has to be less than or equal to 13, so that's no good. 5 and 14, that's also no good for the same reason. And if you keep going, you get some good ones. 6 and 13, 7 and 12, 8 and 11, and finally 9 and 10. These ones all are valid according to our rules. So put check marks beside these guys. Check mark, check mark, check mark, check mark. Okay, let's keep going here. Next one, of course, is 24. And that would mean n is 9. The only ones that will work according to the conditions are 11, 13, and 12 and 12. And that's for 24 and 9. And that's it. After this, you'll find that they won't work if you try. And I'll illustrate why. So if you put 29, this will be 10. You can try 4 and 25. You can go down to 13, but then this becomes 16. There's no way to satisfy this once you get up to that. So these are the only ones that I checked in red, and I checked 11. So that is the answer, number 23, E. Each of the numbers 1 through 26 is placed in a different circle below. The numbers 13 and 17 are placed as shown. Jen calculates the average of the first 3 circles, the average of the numbers in the first next 3 circles, and the average of the numbers in the last 3 circles. These 3 averages are equal. What number is placed in the shaded circle? The first thing to do in this question is add up all the numbers that they have given. And when you add up those numbers, then we can divide those in 3 parts. So when you add up all these numbers, you get 111. So 111 has to be divided equally among those 3 sets. So 111 divided by 3. So each of those 3 sets has to have a sum of 37. And that's it. So therefore, this has to have a sum of 37. So that means 13 plus 17 plus that circle, let's say x, is 37, and therefore x is 7. So this number that goes in the shaded area is 7. And just for the sake of completeness, you can make the other ones 5, 6, and 26. That will add up to 37. And 1, 14, and 22. That will add up to 37. And when you take the average of those, they will all be the same. So number 21, the answer is 7. That's choice D. A purse contains a collection of quarters, dimes, nickels, and pennies. The average value of the coins in the purse is 17 cents. If a penny is removed from the purse, the average value of the coins becomes 18 cents. How many nickels are in the purse? So we got pennies, nickels, dimes, and quarters. So the number of pennies times 1, which is the value of a penny, plus the number of nickels times 5, which is the value of a nickel, plus the number of dimes times 10, plus the number of quarters times 25, is the total sum of the amount of money. And of course, you have to divide by the number of coins, which in this case would be the number of pennies, plus the number of nickels, plus the number of dimes, plus the number of quarters. And they say that when you do that, you get 17 as your average. All right, so that's your first equation. I'll multiply this out, and I'll get P plus 5N plus 10D plus 25Q is equal to 17P plus 17N plus 17D plus 17Q. And putting everything on one side, you'll get 16P plus 12N plus 7D minus 8Q. Okay? And that's equal to 0. And I think that's about as far as we can go there. Now let's take into consideration the next piece of information in the question. If a penny is removed from the purse, the average value of the coins now becomes 18 cents. So exactly what we did here, but instead of P, it's P minus 1, right? Because 1 penny has been removed. Everything else is the same. 5N, 10D, 25Q. And then the denominator, this time, we have one less coin. So it's P minus 1 plus N plus D plus Q. And that, they tell you, is equal to 18 cents. Okay? So this becomes, let's see here, P minus 1 plus 5N plus 10D plus 25Q. And that is equal to 18P minus 18 plus 18N plus 18D plus 18Q. All right, let's put everything on one side. 17P plus 13N plus 8D minus 7Q. And then, let's see here, minus 18 plus 1, so minus 17 equals 0. All right, I got two equations. I'll call this equation 1. I'll call this equation 2. Now I've got to combine these because both of these conditions have to hold true. How do I combine them? I'll just do 2 minus 1. I think that will allow me to at least get rid of one variable. Or maybe not. Well, we'll see. Or maybe it doesn't help me at all. Who knows? Let's say 2 minus 1. I've got to combine them somehow, though, because otherwise they wouldn't give both pieces of information in the question. 2 minus 1, let's see here, P plus N plus D plus Q minus 17. All right, that looks good. I like the way that looks. So that means that P plus N plus D plus Q is 17. So that means there's 17 coins. Okay, that works out pretty decent, I think. Now we have to figure out how many nickels. All right, so I think at this point, because there's so many variables, this has got to be done entirely by inspection. Because if you have 4 variables, you would need 4 equations to figure out each variable. All right, so let's make a little table here. Hopefully we don't have to rack our brains too long to figure out the answer. Okay. All right, so we got 17 coins. And we know that the average of these 17 coins is going to be 17. So that basically means that if I take the sum of the value of the coins, which would be P plus 5N plus 10D plus 25Q, and divide by the number P plus N plus D plus Q, that average is 17. All right? That means P plus 5N plus 10D plus 25Q is going to be 17, if you cross multiply, times this, but that we know is 17. So it'll be 17 times 17 like that, which is 289. So I've got to figure out, how do I get a sum of 289 if I use pennies and quarters and dimes and all that stuff? Okay, well, the first thing I notice is that everything is a multiple of 5, right, except the pennies. Quarters, dimes, and nickels are a multiple of 5. But I've got 289, and that's not a multiple of 5, so I'm going to subtract 4 pennies from that. So I'm going to let P equal 4. And if I do that, that means I've got 285 cents remaining that I've got to make with the nickels, dimes, and quarters. Now, it shouldn't be that hard to figure out how to do that. How about if I use a whole bunch of quarters If I use, say, I don't know, if I get close to that, 275 would be what, 4, 4, and 3, so 11 quarters. 11 quarters would bring me to 275, so that means I've got 10 cents left. I can make 10 cents with 2 nickels. All right, that is definitely true, but I've got to figure out this in a way so that my coins equal 17, the number of coins. Let's see, 4 pennies, 2 nickels, 11 quarters. That is 6 plus 11. That is 17 coins. Great. I think I've done it without too much pain and suffering. So there you go. We've got 4 pennies, 2 nickels, 0 dimes. Yeah, 0. I'll put a 0 in there for dimes, and 11 quarters. And what they wanted us to figure out in this question was the number of nickels, and that's 2. So therefore, number 25, the answer is A. Selena bought 300 grams of candy A for $5 and X grams of candy B for $7. She calculated the average price of all the candy that she purchased was $1.50 per 100 grams. What is the value of X? I'm going to change everything to cents. So $1.50 will be 150 cents over 100 grams. So that is 1.5 cents per gram. So now we have to take all of the candy and talk about it. So we have now 7, we're doing the dollar amount on top, right? So 500 cents for this, and then 700 cents for that, candy B. And then we have to divide by the total number of grams. So candy A was 300, and candy B was X. And this has to equal 1.5 cents per gram. All right, so now we do the math here. 1200 over 300 plus X is equal to 1.5. Cross multiply, and we get 1200 is equal to 450 plus 1.5X, and therefore this gives me 750 is equal to 1.5X. Therefore, X is 500. And therefore, number 22, the answer is C.